right, so everybody got quiet for me. I don't need to say we're going to get started. And then a minute here. Okay, let's go ahead and get started. My name is Chris Rimondi. The title of my talk today is Using DevOps Monitoring Tools to Increase Security Visibility. A little bit of way of an introduction here. First, I work for FireEye. I actually work remotely out of my home in Chattanooga, Tennessee. I have a wife and 3 kids. All 3 of my kids are boys at this point, and the oldest is 5, so 5, 3, and 1. We're kind of excited because this summer we're going to be adding number 4, and number 4 is going to change things in our household a little bit because it's going to be a girl this time. So we're looking forward to that, and you know there's a little bit when people asked us, they say, okay, you've got 3 boys. What do you want to do? You know, what do you want your next one to be? And well, we do the normal parent stuff and say, I don't care as long as the baby's healthy and happy. And then they say, okay, shut up, tell us what you really want. And they said, and we said, well, we actually prefer another boy because we kind of got the boy thing down. We've got all the boy clothes, right? And there's like a certain amount of predictability to having 3 little boys in the house. They do things kind of similarity without fail, At one point or another, all 3 of them have eaten sand. At one point or another, we have a hole in our kitchen window screen where all 3 of them have eventually put their hand through. And we, at some point or another, we've had to actually drag all 3 of them away from the toilet because they like to play in it. And it's, those type of things, you kind of prepare yourself for, and we get prepared and try to, make the, it's going to be I guess with the little girl, things might be a little bit different. But we're excited about that, and I've, tried to look at that. My career in security, I've actually started with Mandiant a couple years ago, came over with the acquisition to FireEye. Started as part of a team, actually work on the same team as Jason Smith, who was here, who just presented before me. And that team was kind of a startup a couple years ago. I came in more as a customer-facing role, and I've shifted more towards an operational role. And the reason I put this talk together was because I was doing operations, I was seeing a lot of the different angles and different tools and so forth that they use on the operational side for operational monitoring. And I thought to myself, thinking about this, is it possible to leverage certain tools from the DevOps standpoint that we use on a fairly regular basis to monitor large distributed systems and apply them back to the security side. So it's kind of like a awakening, and then me coming in initially as a security person and seeing some of the problems that operational folks have to solve on a regular basis, I thought a lot of that actually might be valuable. And when, you can kind of put together a few different problem spaces on this. And from a why standpoint, why do we care about security visibility? Why do we care about how we get data into our systems? The first one is basically collecting data can be hard. A lot of applications, operating systems have syslog facilities and so forth, and agents that can run that. But usually getting the data that you care about can sometimes be pretty challenging. Managing that process and working through it can be a challenge to anyone who's trying to get the data into the system, and doing it in a way that's automated and configured as you expect, so you have some end goal in mind. Like, you don't just collect data for collection of data's sake, you collect it for a particular purpose. And then, storing that data can be very expensive. I've had this discussion with people, and at first that might be kind of unintuitive. They might say, well, hard drive prices are going down. We're decreasing the cost of storage. Is actually storing the data really that expensive? And if any of you have put in a SAN or have done cloud storage, the answer is absolutely yes. And the actual price of the hardware itself is not really the only factor. In fact, it's probably one of 6 in terms of understanding how much storing that data can cost. And if you don't store it appropriate to the task that you're looking to do, then it can be even more expensive. Have some familiarity with relational databases, NoSQL databases, sometimes uninverted indexes, and so forth. And every one of those tools has a particular purpose. And if you pick the wrong tool for the job, then you're going to it's either going to be inefficient or it's going to be incredibly expensive to store that data. And then really the third purpose or third question problem we're looking at is anomaly detection can be complicated. I think as an industry, security, we're still just starting to come into our own from an anomaly detection standpoint. It seems like it's one of those things, a lot of people are talking about it. It's kind of lumped into the analytics space. Anomaly detection is something that when you're attempting to do it, you have to have some type of baselines early on to get anomaly detection to do it right. And really, if you go out and you say, okay, who's actually doing anomaly detection? Who's actually using it to detect real evil in their environment? Few people are. But in reality, in the operations space, anomaly detection is critical, right? There's no concept of really antivirus or signature-based type of stuff. If there's pathology in your system, you need to have an understanding that, okay, this is baseline and this is bad, right? So anomaly detection is something that's being utilized, I would say, on a fairly regular basis. And if you're doing it right, you're going to have some idea on what your baselines of your systems and what they're performing and so forth. And therefore, I've really put together 3 goals of this presentation. The first one is kind of give everybody here an idea of maybe some cross-platform collection of metrics, what it looks like to collect metrics on Windows, what it could look like to collect metrics on Linux and so forth, and give you an idea, just maybe get you started along the tool path that can help you do that. The second thing is really looking at cheap and efficient storage. Again, I've seen more very direct responsibility to this, but I've seen a lot of inefficient storage, and this can actually be a fairly cheap endeavor if it's done right. Sometimes you guys are probably pretty familiar. Security incident and event management tools can be very expensive. Log management tools can be expensive. If you're trying to do anomaly detection and you're doing that with like a free text search engine, that's not going to be the most efficient use of your resources. However, some of the operational metrics that are out there are actually specifically designed for time series-based data collection points. So I want to bring that up as part of this. And then finally, give you an idea of how these tools can do some basic analytic capability, kind of focusing on anomaly detection. All right, I've got some baselines. Let's look at a few different ways on how we can do that. So kind of getting started now, and also want to point out everything I've gone over here is open source and free. You can go download this stuff. I didn't want to bring any proprietary tools. The point is just get everybody out there and playing with it and having an idea of how this stuff works. So first question is, how do we collect? I want to introduce you to a tool, StatsD. Does anybody have any familiarity with StatsD, if you use that in an operational standpoint? All right. StatsD is an extremely simple application, and its entire job is just a daemon. It listens on a UDP port. It listens for messages. It parses messages, extracts metric data, and flushes that data to Graphite. And I'll explain what Graphite is in a minute here. But StatsD is, again, it's a simple node app. It's less than 1,000 lines. It can collect locally on the box, or you can point other agents at it, and all it does is just basically take data, process it, send it to the database. That's all it does. Now, I've got a really simple architecture diagram here, and I want to just go over this quickly. You can have StatsD collectors a number of places in your network. On the application side, really kind of the 3 levels of logging which I want to focus on is the application side, the operating system side, and the network side, and we'll talk through some of that. But StatsD basically takes that data and it sends it to Graphite, and Graphite's the database tool I want to talk about here in a few minutes. But kind of some questions. Many of you are, if you're not in web shops and so forth, you might not actually have applications that support StatsD. What if that's the case? In my world, we'll have when the application is being developed as you're telling it. I have, as an operations guy, I go to the developer and I say, all right, tell me what your application does, and they say it does X, Y, and Z. I say, okay, here's the operational metrics. I want StatsD here, 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 and here, and they have the libraries for StatsD. They put it in, and then I have telemetry. But the reality is, many of us support enterprise environments. We don't have that type of luxury of telling our developers as they're developing an app, this is where I want metrics from it. So what if I want to collect data on operating system metrics? What if I care about syslog on Linux or Windows event logs on Windows? What if I care about that? These things don't have native StatsD integration. They don't have native time series extraction. Those are the things that you might be interested in doing, and therefore, how do you get that? And then what if I want to collect data on the network? What if I care about the number of FTP attempt sign-ons, or maybe I care about the number of status codes that are flying by, or I care about the number of transfer receive bytes? Wouldn't it be nice if that data was in the same place as my failed logon attempts? And what if it was like, I could graph that and interact with it? So again, I wanted to address these type of specific problems more than like the typical use case of how you can get that data. Now, I'm going to review a few different tools here. On the application side, maybe how to get some data from it, looking at Logster, NXLog, and Logstash. I'm going to obviously look at some Linux and Windows use cases, and finally, I want to take Bro, and I've got some examples on how you can take Bro data. Some of you, I guess Jason might have covered it in his previous talk, but take Bro data and kind of basically put metric collection points into it so you can get time series-based data out of it. All right, let's start off with a tool called Logster. Like StatsD, Logster is a tool that's written by Etsy. It's probably the most simple and straightforward methodology to collect statistical information from logs. All it does is tail log files and then sends data to StatsD or Graphite, either one. It is really good for doing like basically any Linux OS or application. If you have a flat file that's just constantly getting appended to, you can fire up Logster. It's an independent agent and it does its thing. What that looks like what the code looks like, I'm not going to go into too deep here, but if those of you who have written Python code, you basically compile yourself a regular expression in Python. Let's say in this particular example, you care about status codes from a web server. You can extract the status codes from every metric. For example, this might be a 200, 300, 404, 503, something like that. And that gets put in, and that Logster keeps track of that data. And then you just simply create, Logster will create a metric object, and it flushes those stats to Graphite or StatsD on a periodic basis, usually every 10 seconds, 60 seconds, something along those lines. So if you're really looking to kind of get started with like simple independent, I have a flat file, I would like to write parsers for it, I care about every time the word failed is in there, I want to keep that track of that metric, Logster is a really good way of doing it. However, I think that it's probably intuitive that it's StatsD integration and keeping track of time series-based values is probably better suited for the log agent itself. So I'm going to review two different log agents here. The first one is a tool called NXLog. I just want to take a quick survey. Who here has actually heard of NXLog or used it? Okay, there's a couple people here. Okay. I was introduced to it about 6-9 months ago, and it's pretty slick stuff. It's open source, it's cross-platform, which as you can see that the packages there's Windows packages, Debians, RPMs, and even Android APKs. And it's, just a phenomenal tool. I believe it's written in C or C++. Very efficient, it's got a very tight footprint on the box. And some of you know some other logging agents know that's not always the case with log agents. And what NXLog gives you the ability to do is parse data, and then extract data from it, and essentially it has outputs for StatsD. So here's a couple different examples. The first one is a colleague of mine, Evan Davison, has some really good examples of NXLog logging on Windows. What it will do is it can tail the Windows event log. It parses that data, so you don't just get, if anybody has experience messing with Windows event logs, it's just messy and ugly. You're extracting XML and so forth, but it will turn that into form data, send that data to wherever you want it to, or it even has the ability to have some pretty robust plugin libraries so you can manipulate the data, finesse it, and so forth before you send it on to your collection agent. Of course, I wouldn't be talking about it if it doesn't have a native plugin for NX for StatsD. Cool stuff here. Again, I've given a Jason Wilder's blog there on how to create real-time web server log metrics. The concept is basically the same. You pick out something that you care about in the log message. You basically do regular expressions on it. You take that data, and you increment it at a certain pace, and you flush those incremental time series data to StatsD or Graphite. Now, and then finally, it's routed over there. Another tool I think that many of you would probably be familiar with is Logstash. I assume most people here are familiar with Logstash or the Elk stack, right? Yeah. Logstash also has a native plugin library for StatsD. And, as I sat trying to think about different use cases, where would it be good to get telemetry data from? The network was probably, it's kind of a difficult one. This is not something you could probably pull firewall logs. You can do flow data or whatever. But Bro data is, for those familiar with Bro, is just a super powerful network analysis framework. One of the things I like about Bro, which is very straightforward, it's simple. It writes events to the log file on the file system. It's a flat file. Now with Logstash, you can actually tail those files, and then it will collect the metrics for you. So it will parse it, and based on fields in those logs, it will parse it, and you can increment. Okay, this is the username I've seen, or this is the if it's looking at FTP usernames, this is number of logins and so forth. There's a good in the Applied NSM blog, Chris Sanders and Jason Smith's blog, and I believe I saw their book somewhere around here, parsing Bro logs with Logstash. They have some Logstash plugins on how to send that data to Elasticsearch. I'll show you guys this at the end. On my own GitHub page, I've taken theirs, modified it some, and actually done the StatsD integration for you. So if you want to kind of get started, if you have Bro running somewhere in your network or at home or whatever, and you want to test this stuff out, you can Bro 2.3 is what I did it for. You can drop that into your Bro you can drop that into your Logstash config. It's got some parsers for Bro, and then I've basically doing the StatsD extraction for you on metrics that I think would be important. So I'm going to move on now to how do we store the data. Before we do that, any questions on the collection piece before I move on to the storage of it? Makes sense? Logstash and Xlog? Okay. How do we store the data? Again, the storage of data is I think it's extremely important. And many times this is kind of system administration type of stuff, but you do need to think about how you're storing the data because it can get extremely expensive. And if you're not doing it the right way, it can also take a long time to process. When I get to the last part of my presentation, I'm going to go over some alerting mechanisms and how you can do that. And the theory behind that is that alerting mechanisms should regularly access the data. It's a polling mechanism. If your data is stored in such a way where it's not readily accessible so you can't poll it on a semi-frequent basis, then that data you're not going to be able to get to it. You're not going to be able to do what you want, even if it is stored inexpensively. So the tool that I'm going to speak about is Graphite. And I think along the same lines as StatsD, Graphite has a very simple purpose in life, just a couple of them here. It is designed to store numeric time series data. That's all it's designed to do. And then it can render graphs on that data based on how you poll it. It's again, like StatsD, it's kind of tooled specifically for this purpose, and it's to be as efficient as possible. Now, the architecture, I'm going to kind of breeze over this a little bit, but I just want to give you guys a flavor of what this looks like. Graphite's actually a Python-based application. It's got really three fundamental parts to it. The Carbon daemon, which accepts metrics from StatsD or other places that are sending Graphite data. It's got a Whisper database that's part of it. Whisper is essentially one of those databases where the database is the file format, right? So you don't really have like an active application that's the database. It's just efficiently storing data. That there's a set of Python libraries to write in the Whisper format, and that's how it gets data down to it. And it's just written on the file system. It's one of the reasons why it's fairly cheap and inexpensive to run, because you're basically laying down file data and data on the file system in an efficient fashion. And then there's actually a web app for it. There's a bunch of different front ends. It does come with its own Django web app that basically allows you to render graphs on demand. So what this looks like from an architecture standpoint is that the Graphite web app actually will, or the Graphite application, the client, such as StatsD coming from several different places, sends data to Carbon. It lays it down as a Whisper. You have the file system. Again, the file system is the database. And then there's a web app, or I'll show you some alerting mechanisms on how this works, that regularly polls Graphite to get data about it. And then the user can view either the Graphite web application, or you can put a different front end on it. But that's essentially how you're looking at metrics and so forth in Graphite with this kind of like Graphite StatsD ecosystem. Now, I think that really getting into really the meat of the presentation and what I want to convey up front here is okay, so now you're collecting the data, you're efficiently storing the data. How do I go about alerting on that data? What are some of the use cases from a security standpoint that I can actually work with this? We have, to give you an idea, kind of like web shop, we have a number of distributed systems. And what we've done is we get application metrics and so forth. And every application, we have different stacks running, and every application might have different. For example, one might have an average of 5,000, which whatever that means, we'll leave a metric off it. The other might have an average of 10,000. So the philosophy behind this is, if you want to have kind of a unified metrics or monitoring system, you can't base it. If you want to go without foreknowledge and out saying, okay, I know what every application is, you need to make it done in such a generic way as you can put an arbitrary metric in there and get essentially anomaly detection based on it. So going forward here, that was my goal when I put this in, because we have a lot of different application and metrics and so forth. That's what I attempted to build. And you're going to see where I'm going with this in a little bit. But there's a lot of, that's not a lot, I would say there's 2 or 3 major monitoring applications for Graphite. One of them is a tool called Siren. Siren is written in Java. Its focus is just Graphite alerting. It comes with a UI, and I'll walk you through what this looks like. So let's say that we're back on failed logins, and I want to say I'm going to put failed logins in the name box here. I have a description, failed logins on my domain controllers. You give it a target. That target there is the Graphite namespace that you're actually looking at. So it's Acme Corp DC.star. Graphite has this cool ability to do wildcards. So for example, let's say that your naming convention in your data in your enterprise data center is DC01, DC02, DC03 for the different domain controllers you have. Star might be all of them. If you're using that as your namespace in Graphite, it might say, hey, this is all of the domain controllers that I have, and then you might be tooling this on failed logins. Okay, so now you're collecting that failed login data. Now the bottom part there, the from and used or from and until is a time series data. You might want to only run this check during business hours or whatever. But the warn level and error level, let's just put some arbitrary data in there, but let's say that you're measuring, I don't know, if you get more than 5 failed logins per minute, that's something that you want to know about. Kind of traditional SIM stuff, we're going to get a little bit more in depth than that, but that's basically the idea. Warn at X level, alert at another level. Siren actually has some capabilities to do some different type of alerting mechanisms. So it can plug into a lot of different areas. Essentially, again, the workflow is you provided a Graphite formula. You set up and tell it how to alert and what you want to alert on, and it can alert to different systems. Obviously, email is the most basic. You can also send to PagerDuty. If you have a particular chat client, I think there's a bunch that are different supported there. It can send to a log file. It can do to SNMP and all that type of stuff. And then you configure the alerting thresholds. I care when this heuristic is above X, and that's when it warns you or sends an alert to one of those methodologies. And it's fairly granular. It gives you the ability to do that. Now, moving on, just to remind us of the architecture. The architecture is again, Graphite's the back end, and if you can see, Grafana is like a dashboard for Graphite. But Siren is what I'm going to be focusing on here, and how this works is the alert polling goes into Graphite and says, give me information about it. Now, Graphite, one of the reasons I like it is it just comes with a ton of functions. A lot of different basic mathematical functions, such as minimum, maximum, average, absolute value, derivative, integral, log. The 3 I'm going to be focusing on in this presentation, I just want to look at time shift, standard deviation, and Holt winners it's a statistical prediction formula. But before we go on to that, just to kind of give you a warning, the rest of my presentation does include a little bit of math. I'll try to keep it. I'm no mathematician, so I've had to water it down for even myself to understand. But I will warn you, there is some statistics in here. But I'm hopeful it'll go slow and we can keep everybody up, okay? Now, first one I said I would speak on is time shift. Time shift assumes your data is seasonal. Okay, it assumes your data is seasonal. What does that mean? Here's a particular graph. Now the blue is the metric that I'm measuring. I left off, pretend it's arbitrary right now. What I've done in the green is that I said, take that metric in the blue, time shift it back 7 days. So for every, and you can fairly see, you can see how close that tracks. Those are business hours. Obviously, whatever this metric is peaks high during business hours. It tails off on the weekend. And this particular metric shifted pretty nicely, right? I mean, the time shifted value of this 7 days prior to this is actually fairly, tracks nicely to it. So if you can regularly pull the time shift data and compare it to the current data, what can you do with that from a security standpoint? So let's look at that. What I would suggest is this. You can pick an interesting security metric. Let's say you go through the first two sections of my presentation. You're getting valuable data. You got it in you're sending it to StatsD. It's going to Graphite, and now it's in there. And now you've got time series data from an extended period of time. You basically, first thing, you choose an interesting security metric of that. Easy one we'll pick is failed logins. You calculate the delta between the current metric, in other words, what it is now, and what it was sometime in the past. 1 hour ago, 1 day ago, 1 week ago. That's your time shift. Okay? And you alert when the ratio of that delta to the metric is greater than some value. Okay? That's what I'm talking about with time shift. I'm going to show you from the mathematical standpoint. Okay? So what I've done here is this. You take a metric, you time shift, then you subtract from it so you get the delta of that metric. So what it was 7 days ago, and then you divide by the metric. Okay, so that might be plus or minus. Siren only works in one direction, so I'm going to take the absolute value of that. So basically I have an absolute value of a ratio, okay, a time shift ratio. And what you can do is you can put that formula into Siren and say, okay, boom, tell me I want you to plot that formula on a regular basis. And every 60 seconds, I want you to check Graphite and tell me if that ratio is above a certain level. This is just kind of, Siren is not built for UI pleasing. It is a rough and dirty tool, and that's okay. But what I've done here is I've said, look, 1.5, I've put this as kind of arbitrary, is my alerting level. The blue line is what I'm plotting is actually that metric. This is where I think it's valuable from putting your tools, your collection, and your storages in place, because this actually can take, if you use the wrong format, a fair bit of computational energy to get this. If you're doing it every 60 seconds, they're gonna hit pretty well. You better make sure that your backend is efficient and can support something like this. But again, this is a ratio. It doesn't matter if it's failed logins. It doesn't matter if it's network bytes. It doesn't matter if it's dropped packets. It's essentially a ratio. And that this kind of general speaking of what we're going for here from a strategy, this is something that I think is valuable. It's valuable in the operational space, and I think with a wide variety of security metrics, it might be valuable as well. So again, time shift focuses on and assumes that the data is seasonal. And when your current data deviates from that time series data, from the time shift going back, that seasonal data, in a way that's material, that's probably an issue for you to be alerted on. All right, moving on to the next one here. Now, coefficient of variation. This is another kind of statistical formula that assumes recent data is the most relevant. Okay, it's no longer seasonal data is the most relevant, it's recent data is the most relevant. And what we mean by that is that for example, if your data has smooth curves, right, you would expect if you see quick increases on your graph or quick decreases, that would be a reason to trigger a coefficient of variation check. And the reason I say that is because, for example, that there perhaps something, if you're being scanned from an IP address side, maybe you've got. I once heard the definition of an incident as something that's attempted evil and something that's abnormal. So for maybe everybody gets port scanned on port 22 on the internet, right? But if the port scanning picks up immediately for some reason, not only is that perceived evil, it's also abnormal. And the way you can look at that is that, if it was an hour ago, 10 minutes ago, 20 minutes ago, whatever that was, if you were getting scanned, I don't know, if there was 50 packets a second thrown at you, and now it's 7,000, this is a thing that might be interesting from a coefficient of variation standpoint. It assumes the data is relevant. So, what does this look like from a formulaic standpoint? The coefficient of variation, or nicknamed or abbreviated as CV, is defined as the ratio of the standard deviation to the mean. Okay, and the standard deviation, again, is just a statistical. It basically says how much does this data deviate from the average. And I think that the coefficient of variation is extremely valuable. It's valuable from an operational sense as well, is because it assumes that standard deviation should always be related to the mean. In other words, I can't take the same statistical formula. I can't say, okay, what's the standard deviation for network packets, and then also apply it to failed logins. Those data points are going to be extremely difficult, maybe in the orders of tens of millions of magnitude apart. But if you take the standard deviation of both of them, divide it by the average, now you're having a heuristic that you can somewhat compare to each other. Does that make sense? That's the whole purpose of that you're relating the standard deviation to the average of that data, and now you're looking at it. And it is a dimensionless metric, which means it's kind of like a heuristic. It works well to do alerting and monitoring on because it doesn't have any associated units to it. So what does this look like in Graphite? I take the standard deviation of a metric, and then I divide it by the average of that metric. That's all I'm doing with this. Fairly straightforward. Now, if you want to take that and say, okay, let's apply it to a security context. All right, let's say I have web server logs, right? I've got my web server logs. I've got basically logs that say, okay, I'm back to this HTTP status codes, right? Perhaps if you're being web app scanned, the number of 400 and 500 HTTP status codes is going to increase. So let's say that's the metric you're caring about. It's valuable for you to know what they are on your web servers. So first thing you do is you get that metric, you calculate the standard deviation of it, and then you divide by that metric. And if your coefficient of variation, or CV, is greater than some value, sends you an alert. So what that looks like in Siren, kind of that same principle here. The yellow line, red line, this time I've just arbitrarily said that the alerting line is 4. I care about if that ratio is over 4. I've used this in a number. Sometimes you have to tweak it a little bit, but this is some data I have that basically says, okay, you can see the blue line is plotting the CV over time. If it were to jump above that red line, maybe I'll get an email. Maybe something will go to pager duty. Maybe something an SNMP trap will be initiated. That's the type of thing that you're looking for here. So that's kind of one way to approach it. So going forward, we've got time shift, which says which puts the emphasis on seasonal data. We've got CV, which puts the emphasis on recent data. And I wanted to, the last one I want to look at is something called halt winners. Now, I'm going to upfront. I'm not a statistician. This is not something that that I deal with every day. But the cool thing is, Graphite makes this extremely easy. It does this prediction in the hardware for you. And the reason that halt winners is interesting is because it accounts for both recent and seasonal data. So it says it puts weights to how much it is. For example, it says it does a prediction saying, okay, this data was X 10 minutes ago, or the average of the data metric time series for the last 10 minutes has been X. 7 days ago, it was Y. I'm going to weight those in an interesting way, and then I'm going to give you a prediction of what I think that data is going to be going forward. So it does that in a way with something they call exponential smoothing. That's apparently there's different levels of that from a statistical standpoint. A way to kind of smooth the curve and do predictions. Again, like I said, it accounts for recent trending. It looks at seasonal patterns. One of the things it does do as well in Graphite has a convenient, easy way to do that, is through confidence bands. And confidence bands is kind of demonstrate this to you here. Going back to my time series week data, what I have is the red data is actually the metric that I care about. That's the metric that I've inputted. I've told Graphite, go out and tell me what the statistical, give me a prediction. And it says, here's what I think, here's what I would have predicted it as. Blue is low, green is high, and you can see every single time that that the actual data fell within the halt winners prediction. All right. So now you have a formula that's built in. You can do some basic detecting on. You say, okay, well now I've got some confidence bands that I have an idea. If my data is outside what halt winners predicted, there might be a problem and something I need to pivot on and go to. All right, what does this look like in Graphite? In addition, Graphite has an interesting capability where it doesn't just do halt winners confidence bands, it does what's called a halt winners aberration. And an aberration is basically said, not only can HW give you a a confidence band. It can also just give you a single metric to predict it. I think at such and such time your metric will be X. And when you do a Holt-Winters aberration, you say, here's the real value, here's what HW predicted it to be, give me the delta between the two. Much the same way I do with time shift, but Graphite's already got that built in for you. So that's the Holt-Winters aberration. And very similar to the CV, you always want to relate that to the metric. I've taken the absolute value here, and that gives you an idea of how this can all be done. So, HW and Graphite, what does this look like? What you're going to do is you're going to first choose an interesting security metric. You're going to say, maybe I care about DNS query volume. Maybe malware goes out there and it just sprays DNS queries, tries to find who it's looking for. Maybe you're looking at packets or whatever it is. Pick an interesting security metric. You calculate the Holt-Winters aberration of that metric and then divide by the metric itself. And now, again, you're back to a ratio. Everything I've shown you here is I'm driving at attempting to get an alert ratio. And then when that alert ratio is greater than some number, that's when you should go out and that's when you should send yourself an alert. Hey, there's some type of statistical issue here. Perhaps you want to look at that. Okay? So that's really kind of wrapping up here. I've tried to do some of this and make it simple if you want to try this at home. The first thing I've done is, again, as I said earlier, I've got Logstash templates with StatsD integration. If you have a Bro box running 2.3, you want to drop this in and you want to get statistical information on it, I would offer up that you could just grab that from my GitHub page and test it out, or you can, maybe if you just want to do it yourself, there's certain metrics you care about. Bro's really good that way because it's got 10, 12, something number of log files that you can pull StatsD from, and I've got most of that there. Siren as a Java application, it's got a REST API to it. And part of that REST API is you can actually just hit that REST API and say, give me a check based on this. So what I've done is I've got a shell script for time shift, CV, and Holt-Winters. All of that's actually done. All you have to do in this shell script is assign a variable. Here's the metric I want. Here's my Siren server. Plug it in. It will go create 3 checks for you based on whatever that metric is. So I've tried, at least attempted to simplify this as much as possible. You can also kind of look at it. It's fairly straightforward. Sometimes the API for Siren's pretty ugly, so I tried to make that as simple as possible so folks can get started with this. I don't know what your opinion is on Docker, but I found the easiest way to get Graphite up and going if you're testing it at home is there's a simple Docker image out there for Graphite and StatsD. It's already done for you. The web app's up. It's just there. You just need to point your stuff at a particular port whenever you have the IP address of that box. Easy way to get started with Siren is there's, again, another Docker image. This is how I did this at home. Docker image of Siren, Docker image of Graphite. Do whichever you need to do and have at it. And then hopefully these scripts get you started in a fashion that's fairly straightforward. So I'm going to wrap up a little bit early here. This is my contact info. Does anybody have any questions on this? Questions, comments? Yes, sir. I think it should. Maybe I'll prevent. I mean, you can if it's not, just shoot me an email at that, and I'll make sure you get it either way. I don't know if it's going to be on the side on the website or not. Yes.
I'm an app developer, so I'm kind of like new to all the security stuff. But you mentioned interesting security metrics. Do you have like some more examples of what like someone might want to pay attention to?
Like at the application level, or maybe at the security level, or. Yeah, both. I had the internet. I'd bring up some of the bro logs. I have all this out. On the FTP side, like if you're looking at bro FTP logs, different connection, failed logins or usernames, or if you're looking at DNS stuff, queries, what the queries are coming back as. If you're looking at SMTP, there might be keywords in there, there might be senders, that type of thing. I mean, there's the idea that it's been said that all data has some security relevance. It's a question of how you're going to do it. Kind of sticking with that bro theme, connection logs. One of the things I've actually done I forget whether I have it up there, in Logstash. Logstash has the ability, you can I think there's natively it comes with GeoIP tag, like GeoIP tagging. So data comes in, it GeoIP tags it, and you can say this is, pick whatever country. This is Russia, China, Argentina, whatever, right? And it tags that. That's actually probably another interesting thing to GeoIP tag the data based on source or dest IP, and then send that data to StatsD. And now you've got, if an abnormally large number of connections comes from pick your random adversary country, then that might be an interesting piece. But yeah, that's good. I mean, there's a lot of different ways to think about it. Firewall stuff, blocks, that type of stuff as well. I'm just curious, do you use any of it in your app development?
I haven't really started using any of it, but I want to get it.
Okay. Yeah, StatsD has there's a lot of really good libraries. If you're into it and you question, there's actually a really good, very simple, you could probably Google it, there's a simple, StatsD has this concept of counters, gauges, and so forth, which, depending on your type of metric, certain things are applicable. Like certain things are better as a gauge, certain things are better as a counter, or a time series or something. A question. Any other questions? Questions, comments? All right, guys, well, that's all I have for you. Thank you very much.